QRZ is the frequency in use. Hello, CADXA, this Alpha Alpha 4 Quebec. It's 7 o'clock, calling the meeting to order. So thanks everybody for showing up. It looks like there's 9 of us in the room and about as many online also. So let's step through this real quick. What's the next one? Okay. So we're going to start the program here in just a couple of minutes because our speaker's is remote and we don't want to keep him up too late. So just out of curiosity, as you go through and introduce yourselves, both in the room and online, and then afterwards on the Zoom meeting, what are your plans for the Arizona QSO party? I'm Bill, Alpha Alpha 4 Quebec, and I probably won't have time to get on the radio.
I'm Doug, W7IXA. I don't have any plans for the QSO party, but I actually may get on and see what I can do.
I'm Gary, KC7CS, and since I only do FT8, I guess I won't be at that party.
Mike, N7MW. I'm not going to be there. I'm going to be in the bombardier seat in a B-17 that morning.
I'm Brian, W7JET. I'll be running the Arizona QSO party with the Superstition Amateur Radio Club from my station using the WB7TJD call sign as unlimited multi. We won last year, so we're hoping to do it again this year.
Mike, W7KK and KK7AMK, and I'm going to swing by and see what you guys are doing.
All righty. Hey, I'm Paul, and I'm looking forward to attending it. New future possible member.
I am OC in G7E, and I'll be rebuilding my antenna for the QSO party.
Probably should have asked any guests to introduce themselves first. So Paul is a guest with us here today, and hopefully next time he shows up, he'll have a call sign to tell us. Okay, those of you who are on the Zoom meeting, why don't you go ahead and unmute momentarily, introduce yourselves, and tell us what your plans are for the QSO party.
This is Mike, KC7B. I'll be on for some. Late start, probably not till about 10 a.m. because of a conflict early on, but I'll spend some time making cues on CW.
This is Jim, KC1BB. I've been kind of waffling, but I'll probably get on and work most of it. Tell us to cooperate on 20 and 15.
This is Richard, N7NT. I'll be getting on sideband mostly, looking for the last few states on sideband I need to complete my triple play award.
Yeah, Mike, K7ING. It's been on my calendar for a while. I'll probably get on for an hour or two, make some CW QSOs.
This is Bob, NA7RH. I'll probably get on for an hour or two as well. Probably just sideband.
Steve, K7SP, no plans.
Ingrid, W7ISG.
K7RGG, we're dealing with antenna issues right now, so no plans yet.
Anybody else? Let's bring that one down and step through the next one. Okay, so our speaker for today, this is let me let Virgil get the sub window out of the way. This is part 2 of Glen Kilo Whiskey 5 Golf Papa's presentation on Arduinos and ham radio. So Glenn, if you're ready to start sharing, go ahead and I'll sit down and watch.
All right, sounds good. By the way, you need to fix your presentation. It says I'm KW5GF and I'm no. Let's see here. Get my act together. Okay, y'all seeing that okay?
Yes, we are.
Okay, good. And this is actually the part 2 of the presentation. This is a brand new one that I didn't do last time because I was saving it for its debut in Huntsville. And we had a great time with it. And it's Arduino, the next generation. And the reason why it's called that is it takes us to the next level beyond your standard Arduino Uno and Nano, and introduces you to some of the more higher powered Arduinos that we can use in our projects. So we'll go ahead and get started here. And space, the final frontier. These are the voyages of the Starship. Oh, darn it. Sorry, guys, I got the wrong presentation up here. That's the wrong next generation. We're going to have to try this again here. So who am I? I'm a network engineer and a technology consultant for HTC Global Services here in Memphis, Tennessee. I was first licensed as a ham in 1973, and I've got over 45 years in the computer, networking, and electronics field. And I started out with jet engine remote data acquisition, control, and telemetry systems for projects such as the SR-71, the F-14, 15, 16, and a few others. I'm also the author of ARRL's Arduino for Ham Radio book series, along with the occasional QST article and product review. I also have a crew. I also show purebred Maine Coon cats, and you'll probably see one running around here in a bit. And I had the 15th best of all cats, the best Maine Coon female in the world back in 1989. And that included winning a best in show at the Madison Square Garden event, which is the equivalent of the Westminster Dog Show. My current pair are from that same genetic line. They're litter sisters, and they're also world champions. They double as editorial assistants, parts thieves, project build supervisors, and general nuisances. And typical of most editors forced to work with my mediocre material, when it comes to helping with the editorial work, as you can see here, they always just need to sleep on it. And while they do have fancy registered names, they're nicknamed Godzilla and Rodan, and this is for obvious reasons. It will soon become apparent. I think one of the reasons I like the Maine Coon is they're basically Kit Kats. They come from the factory like this. And all you have to do is add food and water and you get this. Godzilla is 3 feet 4 inches long and 22 pounds, and her sister is actually the same length with a 5 foot 9 inch vertical leap. And I told you all of that just so I can tell you this. Both are now world famous calendar girls, with Godzilla as Miss April and Rodan as Miss August in the 2022 ARRL calendar that featured cats and shacks. And of course, that's our CEO, Dave Minster's cat that's on the cover with the golden mic. And so now also my latest book, More Arduino from Ham Radio, is now available from ARRL, and we'll talk a little bit about this at the end of the presentation. That book includes another group of completely new and unique ham radio related projects. Some of these projects are actually multiple projects within a project, meaning there's a whole bunch of new Arduino projects that you can build. And now let's get back to the regularly planned forum for tonight. First, we're going to need to set the Wayback Machine to 1988. Back then, I wrote a magazine article that predicted the future of computer technology. The article was titled, "How Far Are We from HAL?" It was a discussion of HAL, the computer in Arthur C. Clarke's 2001: A Space Odyssey, the computer technology of 1988, and what technological advances would need to take place to create a computer similar to HAL. The article outlined the advancements that would be needed in processing power, speech, voice recognition, and vision technologies. It also covered the advances that would be required in storage. Remember, back in 1988, PC memory and disk storage was extremely limited, and it was expensive as compared to today. Back then, a 1 meg memory module cost about $550, and a 30 meg disk drive cost $450, and that's in 1988 dollars. And we're talking megabytes here, not gigabytes or terabytes. With that 30 meg hard drive, one of today's pictures off of your camera would fill that whole hard drive. And that article even predicted solid state disk technology and the demise of magnetic tape. So now let's fast forward to 2022. All in all, mainly as a real result of some very lucky guesswork and my lucky magic 8-ball, the article proved to be quite prophetic. In fact, the lowly Arduino Uno can and is doing a lot of the things predicted in the article today with very inexpensive components. We don't think twice about using devices such as Alexa, the Ring, doorbell, and other advanced everyday technologies that the article hinted at. For reference, the control data supercomputers used by NASA during the Apollo missions had a 60-bit CPU running at a whopping 10 megahertz with 982K of core memory, not necessarily RAM, but it's actually physical core. And in many respects, the Uno is equally as powerful as those multi-million-dollar room-filling monsters, using far less power than the 30 kilowatts that each of those supercomputers used. And I also often spoke of the computer world eventually unifying under a single programming environment that would work with whatever hardware vendor you chose. And while we're not quite there and probably never will be, the Arduino does come very close to proving that one language to rule them all idea was reasonably accurate as well. So now let's dig out that trusty old magic 8-ball that I used to write that article, dust it off and shake it up and see what it can tell us next. But before we do, did you know that I heard the fluid that they use inside these things can become kind of volatile after a certain age? So shaking this one up just might not be a really good idea right now. So we need to give it an upgrade. Did you know that it's actually fairly easy to open up that magic 8-ball and remove all of the insides? The key component is a 20-sided die that's inside a liquid-filled cylinder. The fluid is actually not much more than isopropyl alcohol and dye, so it cleans out real easy. So why don't we mount a Nano, a 128 by 32 pixel organic LED inside that clear cylinder, and then give it a customized sketch that's based on the instructable website's Magic 8-ball with an attitude. And then we can then load that on the Nano. But before we rattle this new genie's cage, let's take a minute and look back. And for you guys, we only have to look back a couple of weeks because you saw it just back then. But the Arduino has come a long way since its introduction in 2005. There are now all manner of Arduinos and Arduino variants, in addition to the original Uno and Nano that I've used that I have traditionally used to build some really cool projects. And most of these new microcontrollers are supported by the Arduino IDE and are every bit as easy to program and use as the original Arduino Uno. And the Arduino Uno and Nano both use the ATmega 328 chip, which gives us an 8 meg 16 megahertz CPU with 32K of flash, 2K of RAM, and 1K of double EEPROM. It's got 14 digital I/O pins, and 6 of those are capable of pulse width modulation. It's got 6 analog input pins. The Nano actually has 8 with a 10-bit A to D converter, and these analog pins can also be used for digital I/O. It's powered by 7 to 20 volts DC with an onboard regulator or via the onboard USB port. It also has an onboard SPI and I2C bus. Now, recently, several cool new boards come along that should be included in this discussion before we really hit the high level here. The dime-sized Arduino Pico that's not to be confused with the Raspberry Pi Pico, and the quarter-sized Mini Uno also use the ATmega 328, but they also have much smaller footprints. The Pico is literally about the size of a dime. And the Mini Mega at the very bottom there uses the ATmega 2560 CPU that's also used in the Mega 2560, but it's in a package that's about 3/4 the size of a standard Uno. But now it's time for us to take a giant leap. You've always heard me say that when it comes to the Arduino, that you're only limited by your imagination. And I still feel that nothing can be more true than that simple statement. For my first 3 Arduino books, I focused mainly on the Uno and Nano, primarily because of their low cost, simplicity, and ease of use. But there's one thing you don't know and that I would not talk about. And before we move on, please make sure that your seatbelt and shoulder restraint are securely fastened because we're about to hit high gear here. I was on a quest. I have been constantly looking for the perfect next level Arduino processor board. To create more advanced projects, I knew that I'd need more CPU horsepower and memory than the Uno and Nano could provide. I needed more I/O, a higher resolution onboard A to D, more flash memory, more RAM, basically more everything. And it had to be inexpensive. In other words, I seek the grail. During my quest, I'd found Arduino compatible boards that came close to what I was looking for, but were not quite it. The STM32 family that includes the blue pill is inexpensive, fast. It integrates in the Arduino IDE and meets much of this criteria, but the various versions of the board may or may not come with the Arduino bootloader pre-installed, and it uses a slightly different sketch upload procedure, so you might have to go through a couple extra steps to bring it fully into the Arduino IDE environment. The ESP32 and ESP8266 are also close, and they come with Wi-Fi, Bluetooth, and are inexpensive, but they still just miss triggering my Grail detector, which of course is Arduino based. The STM32 is a family of 32-bit microcontrollers from ST Microelectronics based on the ARM Cortex-M CPU series. The blue pill version has a 72 megahertz ARM Cortex-M3, and it's got 64K of flash, 20K of RAM, 32 digital I/O pins, and 12 of those are pulse width modulation capable. It's got 14 analog input pins, 3 UART ports, 2 SPI buses, 2 I2C buses, and it costs about $3. But again, depending on where you get it, the board may or may not have the Arduino bootloader pre-installed, so that requires you extra steps to get it to work with the Arduino IDE. The ESP32 is a series of updated version of the 8266, and it also offers Wi-Fi along with Bluetooth and Bluetooth BLE. It uses a 10 silica 32-bit CPU that's available in 160 to 240 megahertz boards. It's got 4 to 16 meg of flash memory, 38 to 77 I/O pins, up to 18 12-bit A to D pins, 2 8-bit D to A pins, which is a first. Now we've got the digital to analog going out. You've got 10 capacitive touch switch sensors, 4 SPI channels, 2 I2C channels, 3 UARTs, up to 8 channels of infrared remote control, and up to 16 channels of pulse width modulation pins. It even has an onboard Hall effect sensor, runs on about 3.3 volts, and it costs about $3. This is a really good option, especially with the integrated Bluetooth and Wi-Fi. And I probably will have some ESP32 projects in a later book. Oops. And here's some more that came close. Early on, the 80 megahertz 32-bit microchip UC32, which was formerly the Uno 32, it was a contender, but at over $50, it remains too expensive to really want to work with. The Teensy series of Arduinos also comes very close, with the Teensy 4.1 having a 600 megahertz 32-bit ARM Cortex-M7 processor, 8 meg of flash, 1 meg of RAM, and 4K of EEPROM. The board also has 55 digital I/O pins, 18 analog input pins, and a selectable A to D resolution of 10 or 12 bits, and a ton of other features. The 4.1 is so close to what I was seeking that there will most likely be several Teensy projects in my upcoming books. But again, at $32, the Teensy is a bit on the expensive side, so the quest continued, but I did begin to lose faith. About a year or so ago, I was approached by ARRL to write a book on ham radio related Python projects using a specific new microcontroller board. I declined at the time as I felt there was more left for me to do with the Arduino. And quite honestly, Python-based microcontrollers just didn't interest me. So I continued moving forward, working with the Uno and Nano while still hoping to find the Grail. And then one day, in one of my various news feeds, I received something that offered up a fresh clue to finding this Grail that I've been looking for, but it used Python. But it did warrant a further look. On the hardware side, this new microcontroller did fit the bill. It has dual core 133 megahertz ARM Cortex M0 Plus CPUs with 2 meg flash, 256K of RAM, 26 digital I/O pins, and 3 12-bit analog input pins. It also has 2 SPI buses, 2 I2C buses, 2 UARTs, and 16 of the digital pins can do pulse width modulation. It even has 8 user programmable PIO state machines, so you can create your own custom hardware peripheral support. And adding more icing to this cake, It also has an on-chip real-time clock and a temperature sensor. And its onboard MicroPython supports 2 simultaneous processing threads, meaning that it can run 2 separate programs at the same time. But I didn't want to do Python, and the darn thing ran Python. Or did it? At this point, I was still not convinced that I had found the Grail. I did not want to learn Python. I did not care that the board cost a mere $4 if it meant that I had to learn Python. Period. End of story. I'm not interested. Next newsfeed. Further research into this microcontroller caused me to take a second look at Python. To this point, my impression of Python had been that it was a scripting language for PCs. And no, I'm still not interested. But it turns out that that initial impression was not quite correct. Further investigation revealed that Python on microcontrollers is becoming more and more like the basic programming language we had back in the 1980s. It's simple, it's easy to learn, and it's easy to use. But doggone it, it was still Python. It didn't integrate into the Arduino IDE, so we'd all have to relearn everything that we all knew. Now, this can't be the Grail. We got to continue the search. And in the next news feed, it detailed the operation of this microcontroller and revealed that it had features that allowed the user to change the programming language from the official MicroPython distribution to other languages, such as SparkFun's CircuitPython and a C++ compiler. This boot image could be changed with a simple press of the boot select button on the board. But still, there was no Arduino support. This is not the Grail we're looking for. Let's clap those coconuts and ride on. But wait, there's a little bit more. The third piece of the message finally got through loud and clear. Earl Philhauer has created an unofficial translation of the Arduino ecosystem to the UF2 bootloader image that this new microcontroller uses, and it's available for free on GitHub. Then there came the announcement of an official bootload image from Arduino for this new microcontroller. This means that this little $4 board now meets all of the conditions to be my holy grail of the Arduino world. But this new microcontroller comes from the most unlikely source. Could we have all been looking in the wrong place this entire time? Let me introduce you to the Raspberry Pi Pico. Yeah, this is some real serious sorcery here. We got a Pico, a Raspberry Pi playing Arduino. So yeah, it's a Raspberry Pi, but it's the Raspberry Pi Pico, which is a totally different critter. It's based on the RP2040 microcontroller family from, yeah, Raspberry Pi. But let's take a closer look. This thing could still be fake. I really still don't think it can be the Grail. I mean, did somebody spike or punch? What, how can this be? But it does have a dual core 133 meg ARM Cortex M0 Plus. It's got 2 meg of flash memory, 256K of RAM, 26 digital IO pins, 16 of them can do pulse width modulation. It's got 3 12-bit A to D analog inputs. It's got 2 SPI buses, 2 I2C buses, 2 UARTs. It even has USB host capability and 8 PIO programmable state machines that you can use to add your own custom hardware support. It also has an accurate on-chip real-time clock and temperature sensor. And it costs a mere $4, and it's still readily available in spite of the chip shortage. I actually bought a pair at Micro Center in St. Louis back in January, and they had plenty of them in stock. So in my opinion, this does have to be the Grail. It has all the horsepower, memory, IO, and a ton of other features to build some really nice Arduino projects. With the Arduino bootloader image, it can seamlessly integrate into the Arduino ecosystem. Most of the existing Arduino modules and libraries are directly supported. So for me personally, this is the low-cost microcontroller I've been looking for in order to take my Arduino projects to the next level and yet retain the ease and simplicity of the Arduino development environment. This quest has finally somehow managed to reach a happy ending. The future of Arduino projects for me looks very bright for now. But does anybody know what those dark clouds off of the distance might mean to all of this? But before we go there, several new versions of the Raspberry Pi Pico have been released, and they're still in the $4 to $6 range. The Raspberry Pi Pico W now includes an onboard Wi-Fi chip. This Wi-Fi chip supports 802.11b, G, and N. And while the chip itself supports Bluetooth Classic and Bluetooth BLE, the initial release of the Pico W will only support the 2.4 gig Wi-Fi modes. The other two versions are the Pico H and WH, which are the same as the standard Pico and the Pico W with the header pins and the 3-pin debugger connector pre-soldered. But now other vendors are also creating boards based on the Pico's RP2040 processor. The WeAct RP2040 board is a Pico style board with 16 mega flash instead of the Pico standard 2 meg. It's available for $8 from AliExpress.com. The RP2040 Zero board is based on the RP2040 as well, but it's got a smaller footprint and fewer I/O pins, and it's only $6 from AliExpress. The LilyGo, my voice is going nuts tonight. The LilyGo T-Pico C3 has both the Raspberry Pi Pico RP20 and an ESP32 C3 on a single board with an onboard 125 by 240 pixel 1.14 inch color display. The ESP32 C3 is a single core 32-bit 160 megahertz CPU with 400K of RAM, 384K of flash, and 22 programmable I/O pins, onboard Wi-Fi and Bluetooth. And it has an onboard JST connector for external power. Switching between the Pico and the ESP32 is done simply by turning the USB-C programming cable over. An onboard LED will light green or blue to indicate which processor is active. And this is just $13 from Banggood.com. The LilyGo T-Display RP2040 is an RP2040 board with, again, the onboard 125 by 240 pixel 1.14 inch display. And it also includes the onboard JST connector for external power. And it's $13 from Banggood. And finally, the RP2040 development board has an onboard 70 by 40 pixel 0.42 inch LCD display. It also features the QWICC I2C connector, and this is $12 from Banggood. So as you can see, already there's an ever broadening list of choices for the Pi Pico type boards. And just one or two more here. The Pi Moroni Tufty 2040 has a built-in 2.4 inch color display. It's designed to be a color LCD badge. It also has 5 external push button switches and a JST connector for external power. It runs on 3 AAA batteries or a LiPo battery, but it is $28, and the shipping cost from the UK right now is still a bit high, so might want to hold off on that one. The Pi Moroni Badger 2040 uses an e-ink display. It's $16.50, but again, the shipping cost from the UK still just a little bit high. So where does this leave me? I'm currently working on the best of Arduino for ham radio. This is due to be turned into ARRL in December. This book will include the best projects from all 3 previous Arduino books. If you've got a favorite that you saw in those 3, you might want to send me an email, let me know, and I'll see if I can get it in the book. The projects are all going to be upgraded with modern components such as color TFT displays, new text-to-speech modules, and more. And new features are going to be added to the projects. But now remember those dark clouds. Naturally, we have to have a cliffhanger if we're going to leave room for a sequel. Everybody knows that real quests for knowledge are never ending. And it's true in this instance as well. Again, as with any quest, this journey has changed and enlightened me. Part of the reason I'm a ham, work with the microcontrollers, write the books, present these fun forums, and enjoy all the wonderful aspects of the amateur radio community is the personal challenge to research, discover, and continue to learn new and exciting things. This quest has indeed changed me. For lack of better words, I've strayed too far into the light while on this quest. My eyes have been open to new and wonderfully exciting things, and I can't unsee what I have seen. I can't unlearn what I have learned, and I really don't want to. So nothing ever stays the same. In the world of ham radio, kit and project building, electronics and technology in general, nothing ever stays the same. Things are constantly changing. So here we are standing on the edge of the future, looking at that magic 8-ball again. Do we stay here, safe and secure in the Arduino world? Or do we continue forward, walking on that razor's edge into the unknown? So why don't we shake that magic 8-ball and see what it has to say? And there we go. I really do love this new magic 8-ball. Yeah, Pico for the win. And so why not have the best of both worlds? As I've said, everything is changing constantly around us. This is true in the microcontroller world. We'll always have the Arduino, but it seems the microcontroller world is moving towards Python-based microcontrollers. And why not? Python has been called the basic of the new millennium, and it's easy to learn and it's easy to use. A cool thing about Python is that you can run it both interpretively and compiled. This drastically speeds up the creative process and potentially saves tons of time waiting for these programs to compile, upload, lather, rinse, repeat because you had a bug. So is this the end of the Arduino? Absolutely not. But does it say that we have more options than ever in regards to our microcontroller? Yes. Microcontrollers such as the Raspberry Pi Pico are just the leading edge of a whole new generation of microcontrollers. The multiple programming language capability of the Pico adds even more choices to our microcontroller arsenal. Now you can design and build with a single hardware platform and then choose what programming language is best for the project at hand. But for me, the thought of using Python on the Pico, yeah, it is kind of seductive. The Raspberry Pi Pico was designed around MicroPython, and with the ability to switch to a new programming environment later on down the road, it gives us a very flexible and long-lived development environment. The Arduino world is just now beginning to embrace real-time multi-threading, multitasking capabilities with tools such as the free RTOS, which is the free real-time operating system. And the Pico itself, though, is inherently multi-threaded. And in the case of the Pico, you can natively run 2 separate programs simultaneously, one in each core, which leads me to say yet again, when it comes to the world of microcontrollers, you're only limited by your imagination, as long as it doesn't violate the laws of physics. Now, if it does appear to violate the laws of physics, before you give up, you might want to try a bigger hammer, more voltage. You know, if you got a friend with some explosives, you can try that. But really, there are no limits here. So now for me, have I chosen wisely? ARRL and I have plans for at least 2 more books beyond the Best of Arduino book, which I'm working on now. And both of those are focusing primarily on the Raspberry Pi Pico. The first book will use the Pico and probably a few other microcontrollers like the STM32 and the TC4.1 that we talked about earlier. And they're going to be done using the Arduino programming language, IDE, and the Arduino ecosystem. The second book is going to be focused strictly on the Raspberry Pi Pico and the variant boards for it and using the Python programming language. And there's even more books in the work, but I really can't quite talk about those yet, but they're going to be big as well. Bottom line, we're still negotiating the price for my soul on those. And if any of you know where I can find a Kelly Blue Book to get me a price on a used soul, you know, just send it to me, let me borrow it, whatever. But I should be able to tell what's going on here real soon. But for you, your journey is just beginning. You're builders, thinkers, creators, and inventors. You're a perfect match for the Arduino and microcontroller world. So imagine the projects that you can build with the Arduino and the other microcontrollers, and then go make them happen. And so with that, I'm done. We'll take questions and comments if we have time.
Anybody in the room or on the Zoom? You said the Raspberry Pi Pico can switch between languages, and then you have to, it sounded like you have to download the Arduino compiler or whatever it was for it. I'm curious how difficult that is.
It's extremely easy. The Pico, actually, you hook it up to your PC and it actually shows up as a shared drive. And so you just copy the Arduino ecosystem or, the Arduino IDE into a folder on your PC and just literally copy it over into the Pico. As you hold down the boot select button, it enters that copying mode. So it's literally hold the button down, drag the file over, and you're done.
Anybody else have any questions in the room or?
And where do you have any thoughts on where it might be in 30 years from now or 40 years from now, just like how you kind of did when you were starting out with the computers in the 70s? Any thoughts on or predictions on where we'll be?
Oh, good heavens. No, I'm not that good. For me, I think the microcontrollers, they're just going to keep ramping up the power. And, it's going to be a little more difficult to build though, because I think they're trying to get away from the through hole components and more surface mount. So we're all going to have to be surface mount type of people if we're going to be building things on our own. But as far as the power is just going to be out of this world. And languages, I mean, there's new languages. I just heard of one today that they're porting Rust over to the PC, I believe. And I'm not real familiar with Rust, but it's another programming language they're bringing over. And I've just scraped the little bit on Python, and I really like what I'm seeing there. So 30 years from now, I really don't have a clue. That's too far out for me. Sorry.
Hey, Glenn. So I know in your previous presentation, you kind of showed you were, building everything from like rotor controllers to even, some transmitters or receivers. What kind of things is the Pico opening up that, what abilities are, bigger projects or just more efficiently or,
Well, with the speed, you're looking now, you're closing in on SDR level speed. So you can build your own little hardware SDR, software defined receiver. You've got more IO pins. So you've got that speed and IO. One of the things I'm looking at doing is with that MFJ beacon monitor, I can just directly interface to it and I'll have plenty of horsepower. So I can actually run a receiver simultaneously and control all of that. But it does open up a whole new world, and it's almost beyond my abilities at this point of where to take it. So, I mean, instead of cranking out a project every month or two, it's now going to be, take me 6 months to come up with something and get it all fine tuned. But it's, like I say, I'm viewing it as it's going to be the end all to be all for me and my development, because it's cheap enough that rather than buying an Uno for $3 or $4, I just buy the Pico. And I'll either use Python or the Arduino, depending on what I'm trying to do, or if I borrow somebody else's code. So I think more it's the versatility and the horsepower as much as anything else. Hey, I know that guy.
Okay, you mentioned that the Python version is called MicroPython.
That's correct. That's what it ships with.
I'm using what I think is Python, probably 3.9, in the PyCharm environment for some projects at work. And I'm really slow at learning programming languages. How much is it just pretty much exactly the same for me to start using that, or would there be some learning curve on it?
No, it would not be difficult at all. All they've done is they scaled Python down to fit on the microcontroller. And of course, the commands on it are a little more microcontroller oriented, but the basic language and the syntax are virtually the same. So if you can do Python, you should be able to do MicroPython without much of a change.
If I've got this little tiny $4 board that's got a USB connector on it, but I need to be looking at a monitor and a full-size keyboard, how does it interface? I presume I'm using my own laptop and it's plugged into it, but what is it like I remote into the $4 board?
Well, as far as loading your programs and stuff on it, or you're talking about having it do video output?
Now it's on.
Oh, there you go.
Okay, so when I'm at work, it's running on a fairly powerful host computer.
Right.
And I've got a display and I've got a keyboard and a mouse. When I operate, when I want to do the same kind of stuff on MicroPython on one of these little $4 boards, what am I using? What are my fingers touching, and how does it interface to this little board?
Yeah. In the case of the Arduino, you have the Arduino IDE and you actually upload the code over the USB port onto the microcontroller. It doesn't have a display and keyboard on the board.
Okay, so the display and keyboard is on my laptop, and then in the
Right.
Arduino, that creates something, and then I save it, and then I load it into the Arduino.
That's correct. And in the Python, I forget the name of the editor, but you actually create your programs in an editor, and again, just copy and paste them over to the Pico.
Just because you said a minute ago that the Pico appears as a
USB
thumb
drive. Yeah.
Okay, so I just drag the file over after I created it.
Right.
So it's
And
not
then you-
exactly real time where I can click run every time.
Well, it can be run compiled or interactively. So, it's just like Python on your PC in that respect, only it's over a serial port to the your PC controlling it.
Okay, I'll have to figure that out.
It's not hard.
It's intriguing enough to make me want to spend a few bucks and buy one.
Yeah, that's what I thought, for heck, for $3, I'll do it.
Although it's not going to be a $3 purchase. It's going to be about $100. Going to buy all 4 of your books first too.
Oh, there you go. Well, see, now you're talking 4 books, because the new one will be out by Dayton this year, we hope. And then you'll have to get the one from the other publisher that's going to be coming out about next fall. But yeah, actually, believe it or not, at the last count, we're actually talking 7 books across 2 publishers at this point. I need to retire so I have time to do this stuff. But then they tell me if I retire, I don't have time. So I don't know.
Okay. Anybody online? So we've been monopolizing it here in the room. Any of you guys on the Zoom meeting want to join in and ask questions?
I'll probably
Anybody
put them
else?
all to sleep.
Okay, we've got another microphone we can pass around. Anybody else in the room have anything to say or ask? Okay, well, thanks a lot for, let me see if I stand right about here, you can see me. Thanks a lot for the great presentation. And I look forward to to learning more about this stuff. So thanks for attending our meeting twice and presenting to us.
Oh, I've enjoyed it. And, as far as learning this stuff, don't be afraid. It's only $3. So if you blow it up, you've only lost $3. Yeah. And it's really a lot easier. My number one best piece of advice I can give you, don't overthink it. It's really a lot simpler than you think it is. So that's just the way I'd go. Your mic is off again.
Okay.
There you go.
Thanks a lot.
Oh, thank you much.
Thank you, 73.
73, y'all.
Yeah. And okay, so we don't have, that was from last time. Okay, so we're gonna take a few minutes break right now. The cookies are back there. Those of you guys that are on the Zoom meeting, instead of here in the room with us, don't get to eat cookies unless you brought your own. And in a few minutes, we'll come back for the rest of our business meeting. So let's take about a 10-minute break. Okay, calling the meeting back to order here. My mic, okay. I wish those of you on Zoom had been here in the meeting. We were spending a lot of time talking with our new potential member, and he would have liked to have met some of you all in person. Okay, our next step on our business meeting is our treasurer's report. Mike, go ahead.
Okay. Slow month, except for GoDaddy annual renewals of a couple of things, and then the meeting room rental. And we've got that coming up for this month. Late in October, early in November, I'll start haranguing everybody about renewals for next year. Watch for initial emails off the reflector, and I'll contact people individually as necessary for that. But right now, we got a little over $8,670 on hand, and nothing else much going on at the moment.
Okay. Next slide. Israel, are you on the call? I don't recall seeing him, but we'll be emailing out the entry spreadsheet as soon as it's ready, and y'all can start entering that.
So the spreadsheet has been uploaded to the group's IO under the files section. And then Lee also posted it on the Slack. So fill that out, and then there's an email address to send that back to Israel.
Okay, great. You guys are ahead of me. Next step. I don't believe AA7A is here to talk about Visalia. Is there any other business from the room or from the Zoom you'd like to bring up before the club? Sounds like there's not much else to go over. Okay, next step. NQ7R, I think he said he's not going to make this meeting, so he'll be back in November and present the 2 months numbers at that time. And the next slide should be about it. So with nothing else to talk about, I can go ahead and close the meeting. Anything else? Going once? There's still cookies in the room.
Hey, for some.
Reinhardt? Did somebody say something? Okay, closing the meeting.